Hi everyone, today let us discuss few topics related to Introduction to VHDL, Vhic Hardware Description Language from the subject DD and CO. Introduction to VHDL. VHDL is an acronym for Vhic Hardware Description Language. It is hardware description language used to model and design digital systems. VHDL was developed in the 1980s by the US Department of Defense. Benefits of VHDL. VHDL allows for the design, simulation, and synthesis of digital circuits. It provides a standardized way to describe digital systems, making them portable and reusable. VHDL supports hierarchical design, allowing for the creation of complex systems. VHDL syntax. VHDL is based on the ADA programming language and uses a similar syntax. It consists of entities, architectures, and processes. Entities define the interface of a component, architecture defines the behavior, and process describe the sequential execution. Data types in VHDL. VHDL supports different data types including bit, boolean, integer, and floating point. It also allows for the creation of custom data types using records and arrays. Data types determine the range and behavior of signals and variables in a VHDL design. Records used to group elements of possibly different types into a single VHDL object. Elements are indexed via field names. Example of record declaration and usage. VHDL modeling styles. VHDL supports behavioral, data flow, and structural modeling systems. Behavioral modeling focuses on the functionality of a design. Data flow modeling describes the flow of data in a design, while structural modeling emphasizes the interconnection of components. VHDL simulation. Simulation is an essential part of a VHDL design process. It allows designers to verify the correctness of their designs before implementation. VHDL simulations can stimulate the behavior of a digital circuit at different level of abstraction. Vhdl synthesis. Vhdl synthesis is the process of converting a Vhdl description into a gate-level representation. It involves transforming the behavioral description into a structural one. Synthesis tools map Vhdl code to specific hardware components such as logic gates and flip-flops. Test benches in VHDL. Test benches are used to verify the functionality of a VHDL design. They provide simulations to a design and capture the expected outputs for comparison. Test benches allows for the identification and debugging of design issues. VHDL libraries. VHDL libraries contains predefined components and functions. They provide a set of ready-to-use building blocks for design implementation. Libraries can be added to a VHDL project using library declarations. VHDL design flow. The VHDL design flow consists of several steps, including design specification, modeling, simulation, synthesis, and implementation. Each step contributes to the development and realization of a digital system. Iterative refinement is one often required to achieve the desired functionality and performance. VHDL design hierarchy. VHDL designs can be organized hierarchically. Higher level entities can instantiate lower level entities, creating a hierarchical structure. This allows for modular design and facilitate design reuse. VHDL design examples. VHDL can be used to design a wide range of digital systems, including processors, memory controllers, and communication interfaces. Design example can be found in various VHDL textbooks and online resources. These examples serves as a starting point for understanding and practicing VHDL design. VHDL design best practices. Following best practices in VHDL design can improve the maintainability and readability of the code. Use meaningful names for signals, variables, and components. Comment the code to provide explanations and enhance understanding. A second method is used to logic equation and develop a data flow description. Again, the model can be simulated at this level to confirm the logic equations. VHDL tools. Various tools are available for VHDL design, simulation and synthesis. Popular tools include Xlinux, ISE, Vivado, Model Slim, and Quartus Prime. These tools provide a comprehensive environment for VHDL development. VHDL standards and versions. VHDL has evolved over the years with several versions and standards released. The IEE standard 1076 defines a VHDL language. Different versions may introduce new features and improvements. VHDL versus Verilog. Verilog is another popular hardware description language. VHDL and Verilog have similar capabilities and differ in syntax and modeling styles. The choice between VHDL and Verilog often depends on personal preference and project requirements. Industry applications of VHDL. VHDL is widely used in semiconductor industry for the design and verification of digital systems. It is also used in aerospace, defense, and telecommunications industries. VHDL plays a crucial role in the development of complex and critical systems. Limitations of VHDL. VHDL can be complex and requires a steep learning curve for beginners. Writing efficient VHDL code may require advanced knowledge and experience. The simulation and synthesis process can be time consuming for large designs. Thank you for watching this video.